Okay, am I live? Live in 3 minutes. I don't know if I'm live or not. Well, I'll put some music on just in case I'm not live. Oh no, I'm live. All right. Uh-oh. I got an audience member already. Hold on. Okay, Ruth, come.
Wait, Phoebe wants me to play all like this video.
Okay. Minor glitch there. I think I'm ready to get started. Just a minute here. It's my first time going live, so I don't know who's going to show up, if anybody. So this is the Bright Drop camper van. Let me get situated here. So we're in Onshape. You know, I think I need to give everyone this link here. Let me put this in the description. See if I can do that. This is kind of a practice run, so you have to bear with me here as I figure this all out on the fly. Let's see, edit description. Okay, so I'm going to add to the description Onshape Link. Paste that in. And then also, I think I should add the Discord. Let's see. Bring it over here. How do I add that? Invite people. Put a link to the Discord server. Discord. So that link should be working. Okay. So you should be able to see in the description link for Discord and Onshape, and you should be able to pull this up. All right. Okay. So I guess we can get started. This is it. This is the concept. It's kind of crude. It's not all there, but eventually these panels will be supported. There'll be structure, there'll be actuators, and they could fold up for driving like this. And when you get to the site, push a button. You got an app. They open up. They automatically track to the sun, or maybe you just have a static. Maybe you just got two shades on either side like that. So there'll have to be some pretty hefty actuators in there to support all that weight. We can go into perspective view. We can fly in. This is what it'll kind of look like inside. And this is completely open to be reinterpreted however we want. Initially, the thought is to have a queen-size bed that drops down. And then during the day, it slides up. The monitor/TV could slide up. Bed comes down. You can watch TV. More bed goes up. TV comes down. You've got a big monitor. You've got a seat here, which would turn into a couch with another cushion and double up as a bunk bed. And then you've got a toilet over here. Thought is maybe all the plumbing could kind of go in here between the walls. And this would be the kitchen area. So have some kind of fridge underneath, induction cooktop, everything you need up top. Let's see. Oh, so the specs on this thing. Thought maybe we should kind of dive into what this Bright Drop EV van looks like. So I think we'll go I was trying to figure out how to get rid of the watermark. I don't know. Do you guys see a watermark on the live stream? Is that kind of annoying? I haven't figured out how to get rid of that. I was hoping it would just kind of go away, but maybe not. Let's see. Right. Drop. Go to Wikipedia. So there's two of them. There's Bright Drop and then there's Chevrolet Bright Drop. And this second one has better information. Here's the van itself. And here's some of the specs. So we can start kind of checking some of this against what we've got in the model. So again, if you can't see it, but in the description, you should be able to click the link and go in, and you should be able to see exactly what I'm seeing. And as I move it, you should see it move live on your end. And if you do get into Onshape and you see it, go ahead and hit a thumbs up. I'll see that you're there. So here are the specs. This thing's a beast. It's a curb weight, fully loaded. Could be 1,000 pounds or 10,000 pounds or 11,000 pounds. We got two variants, the 400, the 600. 600's a lot longer, but the big thing is the range. In order to get the max battery and the maximum range, you need to step up into the 600. And that information is, I don't see it, but it gets you 300 miles city and like 272 highway, which means if you drive slow, you should be able to get 300 just about anywhere. All right, I got a comment. No watermark on my side. Just your own camera overlay. Nice. Background music is a little loud. Okay, thank you. I'll drop that down. All right, let me know if that sounds better. And for the specs here, this is actually a pretty good resource. In the Wikipedia article, it's got all the RPO codes, which I think stands for regular production option. So when the dealer options it out, they have these codes, determines whether they get it or not. These are all standard. Okay, better. All right, sweet. Pull this off. Oh, I got it in the browser here too. I'll just use that one. Close that. So we start by adding some of the stuff into Excel here. Download Excel, and this is in the Onshape file. We'll launch that. Enable editing. All right, so we can add a tab. Right drop specs. And get back to the model here. And this is free to use software, so anyone can get in. It's all open. The only thing that's not is you can't do renders with the free version. I did render out a few that you can see, but you can't create them without the paid version. So actually this one, you can see the Cannonball Run car there in the background. I took a 360 photosphere when we were in Galveston, so that's kind of cool. Which I think is a really good use case for this. You can park out on the beach, you go out, do whatever you want, and then when you're done, you come inside, you got AC, shade from all the elements and the wind and everything. So we're gonna put some of those specs in here. And oh, I forgot to mention, but this thing is on a crazy sale right now. I've got some of the incentives going on. So MSRP is maybe the max version with everything is I think 80 to 90,000. but they've got 25,000 off. Then they've got another 3,000 off for Costco exec member, another 2,500 consumer cash. Then if you're an LLC, you take another $7,500 off for the EV tax credit, and the thing's over 6,000 pounds. So if you have an LLC, you could write the whole thing off on your taxes. So that could be pretty cool. The problem I see with the way you're folding the solar panels is that you can't charge while driving. True. The thought there is it's flexible. So you could fold it up. There's different options. Like maybe you just delete these two. You just have them on the roof, and then you're charging all the time. But while you're driving, I tried to position them so that they could come down flush along the side, like this. Now, I'm not sure what that does to aero. Looks a little goofy, but that way you could drive. I'm still kind of concerned about the shading you get from this kind of overhang. But in this scenario, the thought is you could drive, and you get enough room where you can still get in and out of the door. So that should be an option too. And the actuator should be beefy enough, and maybe there's a latch at the bottom that you can latch them in. So where were we? Oh, back to Excel. So these are all standard options. We'll fly through those. Standard. But the interesting thing is some of the stuff you get in this document, which I think is kind of the ordering guide for dealers, gives you a little insight into the design and what this capabilities are. One of them's cool, Wi-Fi hotspot. That's kind of neat. So you could have, you wouldn't have to have a separate Wi-Fi hotspot. You could just use the OnStar hotspot. Although in our old truck that had a Wi-Fi, it had to be in accessory mode to work. So if the vehicle powers down, you might lose that, and that could be tricky because you don't want to leave the whole vehicle and the high voltage system on just to run a hotspot. That would drain a lot of energy. Let's see. Flying through, you got a ton of options here. Mostly standard in their, like tire inflation kit. We do have the wheels, so that's actually something we want to capture because I'm curious what the diameter of the tires are. So we'll paste that in. And the wheels, we have two options here. They're all 17-inch, so I think that's just the style, black or white painted. But they are 17-inch, so that's kind of important. Let's see, battery. So you've got two batteries. You've got one that gets up to 166 mile range and one that's 272. And I'm not sure if it mentions it here, but one is a 14-pack Ultium and one is a 20. And the 14 pack and a 20 pack, and the Hummer has a 24 pack in Hummer EV, and I think that's 212 kilowatt hours for the Hummer. So if we're looking at what this one's going to be, the 600 would be equal to the ratio of this divided by that times the Hummer kilowatt hour. So we're looking at 177 kilowatt hour battery pack, which is going to be important when we're charging it, just how large it is. So for reference, the Tesla has, I think, a 75 or 80 kilowatt hour, I forget. So it's pretty much double what the Tesla is. Charging, so this thing doesn't have a real fast charging. I think it's only 120 kilowatt DC compared to other vehicles that can peak around 250. Oh, this is the good stuff right here. So the drive axles, you get a few different options. You get front wheel drive or you get the all wheel drive. The front wheel drive is new, but they mentioned the actual drive unit. So this is an X81F for the front drive only, and then the all-wheel drive is an X80F and an X77R. And I used to work at GM, so I kind of know what these mean. I'm not totally certain on the 81F and the 80. I think the difference is one has a park system in it and one doesn't. So if you have a two-motor system, then only one of them needs to have the park paw, which engages and is for parking. And if you have just the front-wheel drive one, I think that one's got park. And then maybe on this one does not have park, but it's the same unit. And then the rear unit has the park system. But these are from the Hummer. So for reference, these motors are 250 kilowatt capable, which is 330 horsepower. So in theory, the dual motor, you could go 660 horsepower, but they've limited it. So they're kind of derating it, which makes sense for a big, heavy vehicle. The duty cycle is a lot worse. They've also changed the final drive ratio, so you got a lot more reduction up front. So we'll capture this. This will be good for checking later. I'm just dumping stuff here, not cleaning it up. And this is the full all-wheel drive. Which, another thing, in order to get that big battery pack, you have to get the all-wheel drive, which is good. If you're going to be out camping, getting around, you don't want just rear-wheel drive, especially with a vehicle that's going to be at 10,000 pounds. Oh, here we go. Here is the rated horsepower. So front-wheel drive, 240 horsepower, 180 kilowatt. Now we know that motor is a 250, but they've derated it. And the all-wheel drive, interestingly, they're only rating it at 225. So they've significantly derated this motor, which is great for longevity. It's going to last a long time. You know, people sometimes complain about how come you can make a semi-truck go 1,000,000 miles and a car only goes 150. Well, they have these huge, massive diesel engines that are designed to last that long, and they're much heavier and much more expensive. So the other way to do it is you just take something that's rated at 250 and you derate it, and now your duty cycle is much less and the longevity will be much better. So let's paste that in there too. Just grab it. I'll have to clean this up later. All right, let's see what else we got. Yeah, different OnStar options. Oh, the dimensions. Actually, we can check some of the dimensions. We'll come back to that. Make sure I modeled the interior correctly. Curb weight information. So each RPO or option is going to adjust and modify the curb weight. Here's your wheel options. Here's the RPO. So these are the options codes that they can put in there. That might be it. All right, let's jump back into the model then. Let's get back to some of these dimensions here. So this is the 600, 600, 400. Okay, so we want the 600. Section view. You know, I just started using Onshape, so I'm new to it and I'm a bit rusty, so you have to bear with me here. Where is the section view? Oh, right there at the bottom. Section plane. I'll just pick the top here and we'll just chop the top of this thing off so we can look inside. Check that. And what I did was I kind of cartoonishly modeled the exterior. And eventually the idea is to scan in a good exterior model and then put that in there so it looks proper, and then all the internal stuff will all be measured and dimensioned. So the internals, where the supports are and everything, should be reasonably accurate. I got access to one in a tape measure and went to town measuring where everything was. Let's see, wheelbase. I think we just want to open this. Wait, take a minute here. Let's see, assuming you can figure out solar panel placement to generate power while driving, how are you going to get around the lockout, which likely exists for safety that prevents charging while driving? Good question. I don't think it'll charge the main battery while driving. There's a bunch of options that we'll have to go through in terms of the solar setup. Ideally, you would direct DC charge, and you could tie in directly to the batteries with a MPP controller, and you could go right up to 400 volt. That would bypass maybe some of the safety features and probably wouldn't be doable. The other option is you have a large auxiliary battery inside. So if we go back here, so I'm thinking this corner would be the power electronics side. So you have your inverter, your charge controllers, and then some large batteries stacked in here. And that would then have to charge through the AC charger on the vehicle, which is less than ideal, but if we have to do it, it's better than nothing. So while you're driving, it would be charging this auxiliary battery, which in my Tesla, I had a 5 kilowatt hour. In this one, you probably want to double, triple, or maybe 5 times that, so you could get like a 25 kilowatt hour battery, which would be big enough battery that you could extract a full day's worth of sun into that battery. So that would kind of be the plan there. And then once you stop, then you could plug that charger in, you could dump it in real quick at like a level 2 rate charging, which is maybe 11 kilowatts. So that would be how you would extract solar energy while driving, but you couldn't direct charge while driving. Unless you tied into the system, which I don't think GM would let you do that. I mean, you could always hack into it, but I wouldn't want to do that. You want to keep the warranty. Okay, so back to the body, and we'll section it again. We'll just drag off the top here. So wheelbase, let's see, that should kind of match this sketch here. It's been so long since I did this. So 4,826, 190 inches. Oh, that's another thing. I've got Onshape set to metric, but you can type in anything you want and just type in the units and it'll take care of it in the background, so you don't have to worry about it. So a wheelbase 183, huh? I thought I pulled that off of documentation, but that does not match, so we gotta change that. 183. Now I'm wondering where I got 190. I don't know, if I change it right now, it might break something. Let's just see what happens. Oh yeah, oh. Control Z, gotta type inches. 183 inches. Okay, I shrunk that in. That might explain it, because I was having issues with these wheel hubs. Now it cuts into the wheel hub, so that doesn't line up. I don't know. I will undo that. We'll have to look into that later. So that's off. That's one thing. Overall length, 290. Let's just show this sketch. That's not the right one. Sketch 3, hide that. 4, 5. Where's all that information in? I guess it's all here. There. I need to kind of hide that body so we can see the sketch better. Or we'll just go edit. So overall length, what did I put? 290. Okay, so overall length matches. Vehicle width without mirrors. I don't think I had that number when I first did this, so that'll be interesting. Let's take a look at that sketch. So this is a picture I found, and then I just pasted it in there to kind of get an outline. 84. No, okay, cool. We've got an extra bit of width there. So that's good. It's good to be wrong on the small side. So we can fix that later. Overall height. Now let's check that. Edit. I don't have overall height in this one. Oh, you know what I did? I didn't have those numbers, so, well, that's overall height, and this is height of the box. But what I did is I used one dimension to scale everything. So I used the picture as a reference to the height to width ratio, and then I locked that in with a number I got somewhere, which doesn't match, so I can update these. Turn that off. Ground clearance. Okay, that'll help with the underbody. Overhang, internal cargo area length. 168.9. Let's see. Extrude. There's the sketch. So let's edit that sketch and let's see. Internal length here. 163. Oh, I got it short. We got some extra room. Nice. So it's a little bit longer than I anticipated, which is going to be good. Internal cargo area width, wall to wall, 8368. Okay. All right, so we got some extra length there. Door height, bulkhead. Not too concerned with that, but it's good that we've got extra room because it started getting a little tight on me. We've got this siding here, which is pretty thin, not structural at all, and it has these aluminum supports, which are welded and kind of give the whole frame structure. So the thought was cut out largest windows possible in between those supports, and then these are what we can fix things to. And then you've got the wheel well constraints. This one is a little longer because this extra part back here is where the charging port is. So all the charging is there. And if we can tie into that and direct charge, that would be the location. And I don't have the cockpit area modeled yet. You can kind of see this is just a picture that I threw on top of the model to gauge where everything's at. So in here you've got the driver's seat, passenger seat. So quick layout here, we'll go back to the assembly. This is the kitchen area, and it gets kind of thin. So this thickness here is about shoulder width, so you can comfortably walk through. So I don't want anything really protruding out into that area too much. It makes the bathroom / shower a little tight, but the thought there is to have a tray, a water collection tray. Maybe it slides out, or maybe it's okay being that width, but then a curtain that extends out and gives more shape. Kind of like when you're at a hotel and they got that narrow bathtub and then they got that curved curtain that gives you a lot more room inside the shower. Same thought here is to have something that extends out and brings a curtain out to give extra space, so you're not too cramped, and then when you're not using it, you don't have this large enclosed area that's impinging on the occupant space. Oh, another nice feature about the panels folding down is it's kind of like a privacy mode. You can black it out, and I'd say stealth camping, but I think people are going to figure out that it's a camper van when it's got that much solar on it. It's got an air conditioning unit on top and all that stuff. Which is another thing, Aero. So I'm not sure if we have anyone on that was looking at the Aero, but I think someone has access to some CFD software so they could do some Aero. And I think we can get the drag coefficients, the coast down coefficients. They're published for passenger cars. I'm not sure if they'd be published for this. I'll have to take a look and see. But if we can get those and then correlate it with a CFD model, so we take the base vehicle and we have the known drag coefficients, and then we correlate it with a model, get the same drag coefficients, then we can make all these changes and rerun the simulation and see what our new drag coefficient would be, and then build a full vehicle model in Excel of power, battery capacity, all that, put in the drag coefficients, and we could plot out your new range at different speeds. So we could figure out exactly what our new highway and city miles rating is going to be. Let's see what else. Let me chop that back off. We'll just turn that off. And fold these back up. Let me go full screen on this. I think we're done with that. So does anyone in the chat, have you guys gone into Onshape and checked this out? Or if you aren't CAD savvy, is it something you want to check out or not? Fold this back in here. Let's see, then we'll section it back, put the section view back on. Get those out of the way. And then I want to add another plane. We can chop the front off so we can see inside. Like that. Ah, on my phone. Okay. Nice. Yeah, I'm not sure how this would look on a phone. This is my first live, so you have to bear with me here. And this is all just cartooned in. But here's the issue I've got. The roof, actually let me turn that, put the top back on so you can kind of see. The roof here has this angle, so it kind of, I don't know if a full-length queen-size bed really fits, although we just found we actually have a little more width to work with than what I've got in here. But if it can only go up so high, then it doesn't give you a whole lot of room. Also, the sliding door comes up into here. I think ideally you'd want to get rid of that sliding door, the garage door style, and have doors that open up out the back. And then you could get rid of the rails and all the internals here. In fact, let me pull up some pictures of this. Here's a picture of the internal, some of the dimensions. So you can kind of see the bed back here. But you've got this in the way, and then you've also got this rail for the garage door. So that's going to kind of just waste a lot of space. The other problem is, let's say it's snowy and nasty outside, and you've got dirt, grime, wet on this garage door, and then you open it up, it's all going to drip into the inside of the van. So you have to enclose it all off and put some kind of drainage or something that gets all that gunk, you know, contains it and seals it to the outside, not to the inside. That would be another reason to get rid of this door and these rails. Let's see, and then kind of the front view. Looking into the front. So you've got this small space here for build out with the electronics. This goes into the front of the vehicle. And it's got a ton of room up in the cab here too. It's super cavernous. I don't know if I have any other good pictures. Most of them are just real close-up shots of taking measurements of everything that I tried to model in as accurate as possible. We can get rid of that. So that's what we're working with here. And I don't know, maybe the bed rotates the other way, so you sleep instead of sideways, you'll sleep vertical, or not vertical, but in line with the vehicle. But that presents a problem with the couch slash bunk bed setup here. If you get behind, actually it's floating in two planes here. Let me lock that down. Oh, I'm still in section. Accept that. We'll pick this surface. And gosh, how do I get in and pick the bottom? Pick that surface. And where is the mate? Parallel mate, fixed mate. Okay. Hopefully that'll still let it slide around. Let's see. No, I totally locked it. Okay, undo. Undo. Actuator attachment for the solar panel wings will be tricky to get the motion you show if you have one fixed anchor point and one movable point. Tricky. If you have one fixed anchor point and one movable, move the second end of the actuator, second point, and continue. Not sure exactly. I'm thinking of having a kind of like a torque tube. So this will be fabricated similar to an airplane wing. So it'll be sheet aluminum with the struts inside. So it'll be kind of like an airframe, and then there would be like a torque tube that it's fixed to, and it would be a rigid long tube of aluminum. It would have a bearing support in one end and a bearing support in the other end, and then inside of that would be a actuator, would be a motor with a pretty large gear reduction to drive it. I think it needs to be around 1,000 to 1. And I haven't looked yet, but some good points to reference might be actuators that do the blade pitch on wind turbines. Those have to be pretty powerful. Another one is Funuk robot arms. They have built-in actuators that might have the right reduction in power. So maybe you could find something like that we could fit inside of there. I don't know if that answers the question. Oh, so back to this thing. So if you get a top-down view here, top-down, zoom in. And you know what? Let me just chop the top of this thing off again. Edit section, add a section plane, which is any flat surface on the top. There. this side. There we go. So we put it back here to where it clears. This is a little cutout for the door, the sliding door that goes inside. If we do that, then these two beds collide and you kind of have some headroom issue. If we put it out in front like this, then it starts encroaching into the walkway. Let me turn that first section plane off. So now you can see, let's just pretend like you had it all the way up here. That's really tight. And then here, it just makes this whole thing really tight. So ideally, I'd like to bring it back over here. We can do that. You can see in this view, if you had two of these and one was a bunk bed, so chop this wall off there and then snap to this. We'll turn off perspective so you can see it better. There. Now you can see if this comes down, say it comes down and you're sleeping here, and you have someone else trying to sleep here, their head's going to be right into that bed. And then if there's one up here, it would collide. So I'm not sure the best way to do this. But anyone can pull this model. You go to the link, you can pull it up, you can create a copy, and then you can move stuff around, you can make edits. And the idea is someone that wants to contribute and actually design on the master version here, we could give out permissions and people could, we get 5 or 6 people that are actually designing in the same model. Why not just a non-square shaped mattress? Yeah. Yeah, we could buy the mattress and then just cut out whatever we need. I mean, that's a good idea. Let's just do that real quick. Let's open this part. And let's go into the sketch. Because your feet don't need all that extra room. And we'll draw a cutout here. And we will trim off that. Oh, I got rid of my dimensions. I didn't want to do that. How do I trim and still keep that dimension? I can always re-add it. Yeah, maybe not. I'll just add the dimensions back. What was that? And that. And then I don't know what to make that yet, but we'll just try it like that, see what happens. Okay, let me get rid of those fillets. Where are you? There. Okay, well the filleting still looks kind of weird, but we'll see how that looks. Yeah, there we go. Yeah, you could put your head here and put your feet down there and you lose a little bit of space, but as long as you have enough shoulder room, I think that's perfect. And then the trick is, how do we turn it into a couch? The thought was to have the same cushion be a couch behind it that also turns into a bunk bed. So let's see what we could do there. Let's make sure this is positioned right. Okay, it's already locked in at the edge, so that's where that's going to sit. So now we got plenty of space. In fact, we could even bring it back a little bit more. And let's change that sketch a little bit. 400. Oh, we need to add insulation and a wall. So I've heard wool is really good for sound, moisture, thermal, and it's also quieter. If you use that, like that blue board stuff in these, I hear it's really noisy. The whole thing just squeaks and rattles. So I'm thinking a layer of wool insulation and then some kind of paneling that has slots in it with a grid or something that exposes the wool so that it's not real echoey. If you just have solid wood everywhere, it could be real echoey and loud if you have people in there, but if you have slots, it'll act as a sound dampening too. So it'll be insulation and dampen the sound out, keep the cab nice and quiet. So we got to move this out a little bit. And the same goes for this cutout too, so we'll have something covering that and insulating it. Maybe you don't need as much insulation over on this wall because you've got a double wall to the outside anyway. But that we'll need some space there. How much, I don't know yet. Let's see how that looks if we look vertical. I need to get a mannequin model in here showing a person size so you can see where your shoulders are, making sure there's plenty of room. Although these are significantly bigger than a Sprinter van, which is really nice. Sprinter van's the most popular for conversion, but this is much wider and longer, and the height, I think, is even taller inside. So let's see if we could drop another one of these in and somehow turn this into a couch. I forget how you do that in here. Let's see. I think you just import. Oh, here we go, insert. Oh, and the dimensions on this. I dimensioned it as a queen mattress split in half. So it should be plenty of room for a regular sized person. Now, how do we turn it into a couch and keep the length and still have this issue here? Let's make a parallel mate here. Let's see, okay, so it lets us move it still. Get it on top. Maybe this is a little lower too. So there, now you got a bunk bed. So this would be sleep mode. You got enough room where everyone can access the bathroom, take a shower, everyone's sleeping, kids can sleep in. Maybe there's even a curtain here that comes and divides off mom and dad from the kids. That would be nice. Oh, have you explained why you're doing this other than an EV? Cool, solar cool, breaking records. Yeah, so that's a good point. I used to live in Houston, and I used to love going to Galveston, and I used to kite surf. And at the end of the day, you're tired and you want to chill out. The last thing you want to do is pack up everything in your car and drive for an hour back to your house. I thought, how cool would it be to have everything you need right there at the beach where you're done for the day. You just walk into your air-conditioned RV and you chill out, sleep for the night. And there's areas there where it's just open use on the beach. You could camp, do campfires, whatever you want. So you can just chill out in your RV. But I think the applications are bigger than that. I used to do landscaping and I had a work truck. And I think the idea of a work truck nowadays, the beds are so small and you don't have lockable storage. These Bright Drop vans are the perfect work truck because you can get everything in storage. It's all lockable. You don't need to tow a trailer. So typically, you know, landscaping crews, you got your truck, which has hardly any room in the bed. So it has to tow this giant trailer. And then you've got everything loaded in the trailer that you can lock up at night. But with this, you've got everything in one unit. You know, you just get in, you start it, and you go. And with solar, you could do really remote locations. So it could be emergency response vehicle. It could be a mobile medical unit, something where you need power. It could be a mobile machine shop. It could be mobile auto repair, construction. You could load up all your wood. You could pull out a table saw, and you could have 220 volt inverter in here. You could have a mobile welding station. So you get out to the job site. You wouldn't need all the solar panels for that. You could probably charge up and get enough every night at the shop. But that's what's cool about Onshape is it's so flexible. You could just mix and match. And the idea is that it's build or buy as much as you want. So you could buy it all in one shot, or it's all open source. The prints, everything would be in here. And you could send it to a local machine shop, say, hey, could you make me another one of these parts? Or maybe it's a printable part, you just print it. Or it's just a comm item, something purchased. And the part numbers and the vendor could all be listed on the part. So you just, maybe it's McMaster car and you need a new bolt or whatever. You don't got to figure it out. You just click on it and order a new one. So it'd be really flexible. Now for me, what I want to use it for is a camper. So the idea is that we design it open source, and at the end of the whole project, if I get a camper van out of it, that's the goal. So that's kind of the point of the project here. Oh, and it could be used for a solar cannonball run, although I don't know, it would be pretty slow. Just looking at that battery capacity, the solar is the same size array that I had when I was did the cannonball run. That was 6.4, this is 6. But because of the added size and energy required, it would be even slower. Although it's solar tracking and it's up off the ground, so you get rid of a lot of the issues I had with shade on the panels, with ground features obstructing the panels, you know, leaves, uneven terrain. Yeah, I put out the array and I've got a little bump, so that panel's high and then it shades the panel behind it. Those kind of issues. So now how to turn this into a couch. You know, maybe it just kind of folds down. Let's see. I need to turn off that constraint. Parallel. So let me delete that out. And if I rotate it like this, let me do another section here. I'll chop the back off so we can see inside. Bring it like this. Bring it down. Maybe something like that. And then it's still got that strange cutout, but then you've got a couch. And maybe it's just got a hinge pivot and just swings up and locks in place, and then it's a bunk bed. I don't know, but I like it. Now for the power electronics, I think what'll be good there, maybe I'll start a new tab. We'll do electrical, and there's a few different options. Option 1. So ideally is, I'd say this is ideal. This is the best if it works. And this is, you have DC, you have solar, so photovoltaic DC to the vehicle EV DC charging. So this is charge electronics. and power. So this thing is built, a lot of it's built off the Hummer platform, and they have, in the Hummer and the Silverado, they have 220 volt and 120 volt module that they can use. So ideally, if you get that, all you have to do is charge the main battery in the van, and then it has the power export. So there's no need to have any extra batteries, electronics, nothing. All you need is a solar DC to DC charger, which there's a company out there that was working on it. And power, I think. No. What was it? Intelligent, that was the name. Intelligent. I probably spelled it wrong. Never mind my spelling here. Here we go. So this company was doing a DC to DC EV charger, and they pivoted away from it, and now it's a battery backup DC to DC. So they're still doing DC charging from solar, but they've got a battery bank that goes with it. And maybe that's the solution too. Maybe we drop that battery bank into the back of the smaller version, and then you can do DC DC, and you've got an extra auxiliary battery. The problem is it looks like it's pretty big, like 20 kilowatt hour DC or 25 kilowatt DC to DC charging. Our solar array is going to be 6, so this is overkill. So the battery is going to be bigger than we need. The charge controller is going to be bigger than we need. But that represents kind of the ideal solution, I think. And then that's all you need. You're done. Option 2, if I've ideal down to less ideal, is well, it's just that. It's a battery reserve DC to DC charging. So it's basically this, except it has a battery. Aux battery. And then maybe, well, if we can't get this, let's say we can't get that. Well, no, we'll do that. We'll say we still have this. So that's option 2. And then the next option is, let's say we can't get the power electronics from GM. So then you still have DC to DC charging. You still need an aux battery, but now you need an inverter. And we'll want to make that a split phase where it does 220 and 120 volt. Oh, I've got to take a drink there. So aux battery, inverter. Let me distinguish this. This is a built-in inverter. GM built-in. And let me just make all this wrap. Wrap text. There we go. So this would be less ideal. You still need inverter. And then this would be, let's say we use completely off-the-shelf stuff. This is basically what I did for the Cannonball run. So we have, you need an MPPT charge controller. You need an aux battery. you need an inverter. See, is that everything you need? You'll have your, and this, for instance, is a MPPT charge controller for Victron. And I think it's got 2 trackers. Ideally, we have 3 panels. We'd want 3 solar trackers. Essentially, one tracker can only do as good as the panel that's doing the best. So if you have it's only, yeah, it'll bypass the lower panel, but you don't get to take full advantage of 2 different arrays. Now, the 2 tracking arrays typically would be the same, except for the use case where they're, say, folded down around the van. Then you'd have 3 distinct panels at different angles, and you'd want 3 trackers. So maybe this wouldn't be the best. But anyhow, this would take the solar input and direct charge a DC battery, and then you'd have maybe an inverter underneath of it, and that could plug in and charge the van. Another thought was weight, to kind of keep it symmetric. Have the heavy batteries here, and then have all the water and tanks somewhere over here. That way you've got similar weight each side, as well as plumbing. So if we keep all the plumbing right in this area, so you have a sink here, you have shower here, everything's right here. You don't need to plumb stuff underneath the floor. And I want to do as little modifications to the Bright Drop van as possible. So if everything can be built kind of like a Cartridge design where you can put it into the van, you can build it offline. You're not acquiring the van and then doing a ton of modifications in order to make this retrofit work. Keep it as stock as possible. And it'd probably be cool to have one of those recirculating showers where it has a filter, a UV thing that kills anything in the water, and it just recirculates, so you can have an endless hot shower, which would be pretty cool. Let's see. The most difficult points I see is stable mounting of the solar panels and enabling DC to DC charging through the charge port, especially because of the protocols and safety systems. Yes, that is the problem. And I think that's why Intelligent pivoted away. The protocols in the vehicle, they've got these large contactors that ka-chunk, click, and open and close that circuit. And it's not designed for the intermittent solar power, which a cloud comes over and can drop to 0 in just a few seconds, or a fraction of a second, and then it can come back up in a fraction of a second. So you would need some way to tell the vehicle, I'm charging you, stay on, even if you don't see power. And maybe that's difficult to do, which is why they've pivoted to this battery backup. Maybe it's not because of a market demand, maybe it's just the requirements of the vehicle. And I'm sure they might be all a little different. Everyone's standardizing on the North American standard, which is the Tesla port. And I don't know enough about the electronics side to know how that would work, but that's definitely an issue. Now, if you AC charge and you have a backup battery, then there's no issue because you can always supply a continuous voltage to the car. Oh, and then stable mounting of the solar panels. Yeah, let me pull up what these solar panels are. I think I have a spec sheet handy. So Maxeon, which used to be SunPower, they split off. SunPower went out of business. Maxeon is hanging on by a thread. But I'm really hoping they can pull this off and stay in business because they've got some of the best cells out there. They are looking at making these Maxeon air panels. It's a 300 watt, 320 to 340 watt panel, 4 millimeters thick, and it's designed for industrial applications, rooftop mounting, where you can just stick them to the roof. So they're going to be the same high quality industrial panels, not kind of the hobby, flexible panels you see on Amazon. These should be much more durable. They're rated, just like a vehicle, -40C. And originally the plan is they're going to have a peel and stick back. So you peel them off and you just stick them on, which is another reason to keep that solar, I don't know what to call it, wing, or let me turn off section view. To keep this out of aluminum is it'll act as a heat sink and keep the panels cool. That really improves the efficiency of the panel and the longevity. So I've basically modeled up these Maxeon air panels, and this is the junction box. It would be nice if the junction box was on the other side and you could tuck it inside here. But then again, if you're driving with it folded up, maybe it doesn't matter. I don't know if I had this on the right screen. Maybe you couldn't see it. Sorry about that. So these are the 3 panels. The only difference is they sort the cells for maximum output and kind of a budget panel with a little bit lower output. So you get 330 watts per panel, and we've got 1, 2, 3, 4, 5, 6. So that's 1,000 watts, another 1,000 watts. Total, you got 6,000 watts. And the shading issue on this, not sure about that yet, but the tracking should give you a total energy capture of about a 40% boost. So you could really extract a lot of power out of this system. Would your 2 tilting A's really need to be on separate MPTs, or you could combine those and keep them on the same angle? Yes, that's the plan. I was going to put this one on one controller and then these 2 on the second controller. And that Victron inverter that's in there, or the charge controller, can handle the full output on one controller of 2 of these arrays. So yeah, they would track and have matching angles. So in theory, you could put them on the same charge controller and it wouldn't matter. It would only be driving down the road if you wanted to have them in this position. It would kind of mess it up. But, you know, maybe I take that back. Let's say you are driving. Most likely, one of them is going to be getting something, the other's getting nothing. So there's always going to be one outputting more than the other, and the junction boxes on them have a bypass. So let's say this whole panel is dead, and this panel is putting out, say, 2,000 watts because the sun's really low, it's pointed right at it. It would completely bypass this one. So you would still get the full output of this one. You just couldn't independently optimize both. So if you're getting a little energy on both, you would basically be limited to the 2,000 watts on this one. If you were getting an extra 80 watts here, you wouldn't be able to extract it. But maybe that's good enough. Oh, so back to the panels. So they're real thin. They peel and stick. The only thing I don't know is the thermal coefficient of expansion. You know, as it's getting hot and cold, how much do these expand and contract based on the aluminum? Is that going to be a stress point? Is it going to stress out the panels and start breaking the junctions between the cells? I know Maxeon, the way they design the junctions between the 2, it's got some spring to it. I don't have any, but it allows for it to expand and contract. So that might be a non-issue. You know, Aptera's, they're also using these Maxeon cells in their solar car. The EG 6000 XP. Yeah, this looks like an all-in-one. 6,000 watts maximum. Yep. Charge current. 2 at 4,000 watts. Yeah, it just ticks the box, because those 2 arrays on the one panel would be 4,000. There's also the Solarc I used. That one's got I think an even bigger a larger solar input. Let me just put some of the stuff in the notes here. Ooh. 8,000 input. Oh, and it's 48 volt, good. 480 volt input solar, and it's split phase, all in one. And the price looks good. I don't know the quality of these though. I want to keep it automotive quality. I want it to be something that you can put out in service for 15 years. You can put 150,000 miles on it, and it would still be working. Oh, where did it go? Here. So I just paste that in there so we have the information. Design of the solar wing is very important. I agree. Use additional heavy-duty bracing on the van to create the anchor point. For the actuators, do you have to build some breakaway capability? A gust of wind can topple the van if you're anchoring the wings as well, or can rip off the wing entirely. Yep. So, here's a thought on that. I was planning to design for a wind load of 40 mile an hour gusts, and then if it's design capable to handle 40 mile an hour. So the structural integrity, the actuators, everything need to be able to hit it. But then maybe it has a trigger point at 20, it automatically folds up. Kind of like those automatic awnings on RVs. They hit a wind gust and it folds up. And then for the strength, oh gosh, losing my voice. So whatever this panel here is, this will have to be some kind of structural thing that mounts to the van. And this rail here, I think I can get access to those rigid aluminum frame rails that go around the inside, so it can tie directly into the frame rails of the vehicle. So this top platform will be really rigid, and then the front and the back will have some kind of large structural bracketry that covers the front and the back and ties in to the actuators. And maybe if those actuators aren't enough, then maybe you do redundant and you have additional actuators in the front with the same structural member. And that structural member in the front would probably include some kind of fairing that would maybe cover this, or not cover, it'd be open for the AC. And this is just some model I pulled off of CAD Grab or something, but that needs to be figured out too. But anyhow, some kind of fairing for drag coefficient. And then those would tie in to the endpoints with this large torque tube of aluminum that would make it structurally sound. Oh, and toppling the van. So another thing I was thinking about doing was whatever actuator mechanism, so it's designed for a 40 mile an hour gust, but maybe it has like a 45, 50 mile an hour slip clutch in there. So let's say it just gets slammed with a big wind gust. It doesn't lock up. It'll just fold over. Yeah, maybe it'll crash into the other side and break something, but that's better than the van flipping. And we do have the advantage of a huge traction battery in the bottom. So this thing is going to have awesome low center of gravity. You've got drive unit, heavy drive unit in the rear and the front, and then a big old battery. So I'm not sure what the CG height is, but it should be pretty low. I don't know, I might have to end the stream. It's been about an hour, I think, so my voice is going, so maybe this is it for today. Let me check a few things. Yeah, I think I'll call it quits for today. I'm going to do a video on kind of this project and post it to the channel to kind of introduce it to everybody. I haven't figured out what the video is going to be exactly, but that might bring some more people into the live stream, and hopefully we can keep getting comments and suggestions. Oh, and the Discord. I forgot to even check the Discord. And there's a thunderstorm outside right now, so if I totally disappear, maybe I lost power. Yep, there's no chat going on right now in the Discord, but the link's there in the description. So if you want something to stick, any ideas, we can paste it into Discord, and then we can bring it into Onshape. And this will kind of be our master record. It's got all the product data management and infinite undos built in, so if we break anything, we can always go back and fix it. And I will upload other documents like Excel tools here, and any other relevant documents we can put into Onshape. And this should be open. Just paste the link in and you can sign up. I think you can see it without signing up. And I think that's it for today. I think I'll call it quits and end the stream. And thanks for all your help. All right, how do I end it? So I just end broadcast.